All right, this is Chapter 12, Section 2, Frequency and Histograms. So our learning objective is to make and interpret frequency tables and histograms. What I did for this section and what you guys can use as your own note-taking tool is wrote at the very first, I wrote down the vocabulary word and found the definition in the glossary. And this is a good study tool. And I love this book because the book will have examples already in the glossary for you, so it's quite lovely. So let's just go through our vocabulary words. The first one is frequency, and thank goodness, because that's a part of our learning objective and title of the section. The frequency is the number of data items in an interval. So it's how many data items you have. So for example, the data set 4, 7, 12, 4, 5, 8, 11, 2. The frequency of the interval from 5 to 9 is 3. So I have 3 items between 5 and 9. So that's our frequency. It's how often something occurs. A frequency table is a table that groups a set of data values into intervals and shows the frequency for each interval. For example, if I have a data set between 0 and 9, I have 5 values, and this is this is frequency. So I have 5 data values between 0 and 9. Between 10 and 19, I have 8 data values. And between 20 and 29, I have 4 data values. So it doesn't give you the exact data value, it just tells you how many you have. Alrighty, so next up we have histogram. So a histogram is a special type of bar graph that can display data from a frequency table. Now, if part of our learning objective is that we are making frequency tables and histograms, then an expectation of your notes is that you have a frequency table and a histogram. So a histogram is a special type of bar graph that can display data from a frequency table. Each bar represents an interval, so from whatever to whatever. The height of each bar shows the frequency of the interval it represents. So let's see how that looks here. So here is the intervals are on the x-axis and the frequency is on the y-axis. So from 0 to 9 I have 5 numbers. And it's, if you look, it's the same table as up here. So from 0 to 9 I have 5 values. From 10 to 19 I have 8 values. And from 20 to 29 I have 4 values. So it's just a way of graphically representing data. And then finally we have the cumulative frequency table, which is a table that shows a number of data values that lie in or below the given intervals. So in or below. Let me highlight that special. So if I have 0 to 9, I have 5 values. My cumulative frequency is 5 because in or below this interval, there's 5 items. Now, what the cumulative frequency does is it takes your next interval frequency and adds it to your previous interval frequency, and when you add those together you get 13. So, and then we take that previous cumulative frequency, we add it together, so 13 and 4 is 17. So those are all of your vocabulary words. So let's put them into action. So if we're making a frequency table, so let's take a look at this scenario. The number of home runs by the batters in a local home run derby are listed below. What is a frequency table that represents the data? So we got 7, 17, 14, 2, 7, 9, 5, 12, 3, 10, 4, 12, 7, 15. The minimum data value is 2, and the maximum is 17. Intervals of 4 seem reasonable because the difference between 2 and 17 is 15. So you can split that up into 4 almost equal items. In the first column of the table, we list the intervals. So for here, 2 to 5, 6 to 9, 10 to 13, and 4 to 17. Count the number of data values in each interval. So how many data values do I have between 2 and 5? And let's use blue. So we'll use this little black crayon. So between 2 and 5, I have 1, 2, 3, 4. So I have 4 items that match that. So between 6 and 9, we're going to use this little purple one. So this is 1, 2, 3, 4. That comes from between 10 and 13, which is 1, 2, 3. So that's where 3 comes from. And 14 to 17. Green. So that's 1, 2, 3. So let's see, count the number of data values in each interval and list the number in the second column. Done. What is a frequency table for the data in problem 1 that uses intervals of 5? So let's go ahead and create that. So we want intervals of 5. So instead of 2 to 5, we're going to go 2 to 6. We're going to go 7, 8, 9, 10, 11. Then we're going to go 12, 13, 14, 15, 16, and 17. 2, 3, 4, 5, 6. Okay. So these are home runs. These are frequency. And let's do some counting. Between 2 and 6, that's 1, 2, 3, 4. So I still have 4 here. 7 to 11. 1, 2, 3, 4. And 12 to 17. 1, 2, 3, 4, 5. Did I forget? This looks like, hold on. Let's go back to red. Between 7 and 11 is 1, 2, 3, 4, 5. 8, 6 is 14, yeah, 14. All right. So, and that's how you do. You can't, if it makes you feel better, you can order the numbers from least to greatest. That's completely acceptable. All right, so now we get to do the fun part. We get to make a histogram. So let's look at some data. The data below are the numbers of hours per week a group of students spent watching television. What is a histogram that represents the data? So we have all these data values. So we have a set of data values, we need a histogram of the data values, and we need to make a frequency table that will help us construct our histogram. So we want to use intervals from the frequency table for the histogram, draw a bar for each interval, and make the height. So Our minimum hours is 0 and our maximum is 23. So it stands out we should do 6 items per interval. So from 0 to 5, because it's 0, 1, 2, 3, 4, and 5. So that's 6 items. All right, so when we do that, we count 6 who had from 0 to 5, 5 who had from 6 to 11, 3 who had from 12 to 17, and 1 that had from 18 to 23. So you put that on a little table. Our frequency, our highest frequency is 6, so we need to go at least up to 6. And they counted in increments of 2. Easy peasy. All right, we're going to do that for our scenario. So let's make a little table. I'm going to go ahead and put these numbers in order because it helps to see them. My lowest is 80. And then the next one is 82, and I have 2 of them. And then I have an 83 right here. So as I get them, I'm going to cross them out. And then I have a 89. And I actually have 2. Then I have a 90. Then I have a 93. And then I have a 95. Then I have a 98, a 99. A 102 and a 105. Boom, boom. So my numbers go from 80 to 105. So we got our interval here. And then our frequency here. So let's bring it out. So 105 minus 80 is 25. So if I go in increments of 5, I should have 5 intervals. So we go 80 to 84, 85 to 89, 90 to 94, 95 to 99, and then 100 to 10, and I'm going to put 5. That one's going to have an extra one. All right, so frequency. How many numbers do I have between 80 and 84? 4. How many between 85 and 89? How many between 90 and 94? How many between 95 and 99? And how many between 100 and 105? All right, so let's make the little histogram here. So we want it to be 1, 2, 3, and 4. This is frequency. And my intervals are 80 to 84, 85 to 89, 90 to 94, and 95 to 99. And 100 to 105. All right. Putting it up. This one is 3. This one again is 2. Boom. Done. All right, now what each histogram means. So if we need to look at histograms and go, is it uniform? Is it symmetric? Or is it skewed? So uniform data means that it's the same amount all the way across. So each interval has the same amount in it. If it's symmetrical, it means that the halves, so if you split it in half, it's close to a mirror image. And then skewed means I have more data on one side or the other. So the following set of data shows the numbers of dollars Jay spent on lunch over the last 2 weeks. Make a histogram of the data. Is the histogram uniform, symmetric, or skewed? So the first thing we're going to do is put these numbers in order. The next thing we need to do is group our items, and I think we go from 1 to 17, and that is 18 data points. So if we go in intervals of 6, we can get 3, or if we go in intervals of 3, we can get 6. So let's go from 1 to 5, from 6 to 11, and from 12 to 17. So this is interval. Frequency from 1 to 5 is 4 data values. From 6 to 11 is 5. And from 12 to 17, 1, 2, 3, 4, 5 is also 5. So when we're making I wanted that line. There we go. Let's try this straight line. Okay, so I need to go up to 5. So 1, 2, 3, 4, 5. And I need 3 intervals. Awesome. So this is 1, 2, 3, 4, 5. And this is 1 to 5, 6 to 11, 12 to 17. And we got 4. We got 5. And we got 5. So make a histogram. Is a histogram uniform, symmetric, or skewed? I would say that our data values are pretty uniform. How much money should Jay plan to bring for lunch next week? And so if I was him, I would probably bring the maximum $17 because he has an equally likely chance of spending that amount, and it would be better to have more than less. All right, so cumulative frequency table. Let's see how that. The numbers of text messages sent on one day by different students are shown below. What is the cumulative frequency table that represents the data? So here's all the data. Divide the data into intervals. The minimum is 0 and the maximum is 49. You can divide the data into 5 intervals. So 0 to 9, 10 to 19, 20 to 29, and 40 to 49. You mark the frequency of each one, and then you just add that to get the cumulative frequency. So all we're doing is adding up. So let's try that on our own. What is a cumulative frequency table that represents the data below? So I'm going to put the data in order. All right, so it's all in order. And then we're going to put it in a nice little table. So I go from 0 to 15. So I like increments of 4 to 9, 10 to 15. So here's our interval and our frequency, and then here's going to be our cumulative frequency. All right. So from 0 to 4, change my color so you can see. I have 1, 2, 3, 4, 5, 6 items. From 5 to 9, I have 4 items, and cumulatively I have 10. And from 10 to 15, I have 1, 2, 3, 4, 5, 6. So that's 16 items. Da 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 da. And that's it.